Okay, so this is obviously extremely powerful. It's still a little bit abstract, but you can already start to imagine all the ways we can apply this. If we can learn any abstract system, we can potentially learn about a lot of things in our world, right? Especially the things that we deal with, very complex urban systems that have a lot of data. There's a fundamental problem that I want to express to you guys right at the beginning before we get too crazy into this and kind of think of it as a holy grail. It only works with things we can convert into numerical data. Okay, so say there is something about a name that predicts high school diploma attainment. Unless we can turn that into numerical data that makes sense and is continuous, or can be broken down into a finite set of categories, we can't train on it. We can't make the computer understand anything that can't be converted into number. So there's this awesome quote, not everything that can be counted counts, not everything that counts can be counted. There's still limitations based on the fundamental types of data that a computer can theoretically understand. Okay, so despite these kind of fundamental limitations, which are definitely things to think about, machine learning in the last decade has really taken off and become applied to a huge number of fields. So we can look at a lot of different applications of these as inspiration. We already talked about a few. You might have heard of others and not even realized that they are machine learning applications. Web mining, any search engine, this is how Google got famous. They actually wrote a really good machine learning algorithm to structure the way that their web crawler would understand information about websites and then deliver the best fit, the best prediction of what you actually want to look at based on your search query. It's a machine learning problem, one of the first most advanced, most well-functioning ones that we have. Screening, say, of customers. So the way that a bank makes decisions about who to loan money to is a huge machine learning application, basically taking historical data about a number of customers with, like, say, 100 different features, age, race, gender, everything you can imagine, and then the final decision, did they default or not? And then any new customer, you feed in that same parameters, and you can get a result out. Okay. Should I give the loan or not? Are they likely to default in the future? Image analysis, this is actually very related to urban planning and urban analysis, but you might have not known this is actually a machine learning approach. I think this is actually built into ArcGIS, where you can train ArcGIS to recognize certain patterns in, say, a satellite image. A lot of energy companies use this for load forecasting, right? An energy company doesn't keep all their systems at full potential all the time. That would be a huge waste. So they actually use machine learning process to predict what days and times of the year that customers in certain parts of the city will use energy, okay? And then cycle up their plants basically to produce just in time. Okay, diagnosis, looking at, this is also kind of an image analysis to diagnosing certain types of diseases based on, it can be image analysis if it's like a CT scan, it can be also traditional machine learning. They've done basically predicting cases of type 2 diabetes based on neighborhood indicators and things like this. Marketing sales, of course, a huge one. Recommender systems fall into this. This is the Netflix, Amazon systems, which have been some of the most publicized, but definitely not the only applications. But that all falls into this issue of marketing and sales. Something interesting I found while reading about this is, those kind of card loyalty programs that a lot of places will have, like restaurants, Starbucks card, things like this. Why do you think they have those, right? It's usually like 10% off. What do you think is like the payoff for them to offer you that 10% off? It's really about the data, because now they can tie your purchases to your ID, right? If you just come in and pay cash, they can't, there's no kind of feature data. They know someone purchased it, but they don't know anything about them. Even if they track credit card numbers, a lot of people have different credit cards and things like this. But with the loyalty card, they can actually tie all your purchase history in time to your specific ID. It is also in science, and like we can think of this as like the closest to our application. Science has really used these techniques for anything from astrology to identifying clusters of stars to gene detection, things like that. So number 8, I argue, why not city design and planning? Why isn't this part of the way that we make decisions about the city? Just very quickly, one application, which is work that I did for the last couple of years, and actually Alex helped me on last semester as a research assistant. We were basically working with a biologist who was trying to understand this large amount of image data that they had about the growth of these specific bacterial colonies. And basically the situation was these colonies, as they grow over 6 days, develop these very complex topologies in their shape. So they did a screen of this bacteria and produced 5,000 iterations, and there's a picture every day to monitor the growth. And this is some amount of data that's not that much, but it's way more than the biologists in their lab can analyze and classify. So we thought about machine learning applications to actually classify these things automatically, but before we even thought about classifying them with machine learning, we need features, right? These images don't have any metadata attached. We know the gene number, but we don't know anything. There's no number associated with the size or shape or whatever, color or whatever else. So we had to derive some of that feature data directly from the image itself. And this is the point of the project, which I think is the most interesting in terms of machine learning application, because we had to learn from the image itself. And there's no metadata. It's not like we know the height and age and maybe we can come up with a high school diploma. It's a little bit intuitive still, but the power of machine learning is that it doesn't have to be intuitive, right? We can feed in any data and just see if something works. So what we did is looked at the pixel information itself. Okay, so we decreased the resolution to some extent, and we looked at each feature as a pixel, the value of that pixel. And we had some amount of, by the way, what we're trying to understand in this specific application is the boundary of the cell, okay, or the colony. There's something important about the size of it. So we're like, can we get the size of it purely automatically without going and tracing each one? All right, and what we decided was we took like 20 colonies, and we traced the boundary, and then we ran it through a system which for each pixel in the image, a cluster of pixels, we trained it to understand, is it inside or outside? That's it. 2 classes, in or out, right? And we had like 20 trained examples. We traced them ourselves, and we trained the system based on those. We set up a few runs where we actually tweaked the parameters, the resolution of the pixel clusters, the number of trained examples, and see if it works. So the red outline ones are ones that we manually traced and fed in as training examples. And you can see the performance here. This is with one set of parameters on the model, and this is with another. Okay, the ones we're training on are the same, and you can see the performance in terms of cutting out the different colonies. You see some work better than others. Okay, but this is the one I thought was like a very interesting application because we literally knew nothing about this. Okay, it was just feeding in RGB values and spitting out these pretty good actually outlines. Okay.